Okay, so today we're talking about calculating change in H. And I'm talking about calculating change in H if you have an equation and you have what your value of energy either given off or stored is. So in this case, I'm going to use this equation. So for the forward equation, we have a change in H of a negative 890.4 kilojoules based upon the number of moles reacting. Okay, so this is going to be similar to stoichiometry. Now, there will be cases where if I'm given grams, I'm going to have to convert to moles. So I might have this equation with this amount of energy, and I might be told, okay, you have 200 grams of methane, the CH4. So how much energy is that going to provide? Well, I don't know how many grams that is. I need to then convert to moles because I know 1 mole will give me this much energy. So what we're going to end up doing is we're going to end up making equalities of the moles to the kilojoules based on the equation. So for example, 1 mole of CH4 is going to give me a negative 890.4 kilojoules, whereas 2 moles of O2 gives me negative 890.4 kilojoules. So we're going to turn these into fractions depending upon what I'm using for my equation. Okay, so we will have to do some molar mass if we're given grams, but I'm going to go through the first problems with you. If you want to put them in your notes instead of on the worksheet, completely up to you. I'm going to leave that up to you, but I'm going to use the worksheet that you have to do the examples. Okay, so looking at this first problem, it's telling us the combustion of methane releases 890.4 kilojoules. So since it's releasing, we know it's a negative number. That is when 1 mole of methane is burned, 890.4 kilojoules are given off to the surroundings. This means that the products have 890.4 kilojoules less than the reactants. Thus, the change in H for the reaction is a negative 890.4. So the first part of this, you're going to draw an energy diagram, label the parts. So if you are putting this in your notes, I would include this part in your notes, and then we can go ahead and draw it. So we're going to need our diagram. So we know this is our reaction, this is our energy. Okay, so since this is exothermic, I want to start high, and then I'm going to have my activation energy, and then I need to end up low. Okay, so that's the basics. Now, since we're not labeling the sides of it, I'm not too worried about numbers. The main thing you have to do is you need to show, so here's your reactants, here's your products, and then we need to show change in H and label that. So my change in H is going to be from here down to here, and I'm going to say change in H negative 890.4 and kilojoules, and done. Okay, yes, I know my marker's too big that my numbers look kind of smudged. Okay, so that's for part A. For part B, we want to know how much energy is given off when 2.00 moles of CH4 are burned. So I'm going to write that out just so that way, if this is going in your notes, you should at least know what your question was asking. We are going to need molar mass for that. Oh no, we don't need molar mass for this, but we might need it later. So how much energy is given off when 2 moles of CH4 are burned? So we're starting with 2 moles. We know we need to cancel, 2 moles CH4. We know we need to cancel moles of CH4. Okay. We need to figure out how much energy that is. So if we look at the equation, we know 1 mole of CH4 is going to give us a negative 890.4 kilojoules. And that's it. So now all I'm going to do is plug this into the calculator. So I need 2 moles times 890.4, and that's going to be a negative number. And I'm going to end up with a negative 1780.8 kilojoules. Done. Easy enough. Okay, for this next one, we're doing how much energy is released when 22.4 grams of CH4 are burned. Still using that same equation that we had, but this time we're starting in grams. So this one we will need to have our molar mass. So we're going to put down our 22.4 grams CH4. Then we need to convert that to moles. So we're going to have, we want our grams on the bottom, so we're going to have 16.043 grams CH4, and that's 1 mole CH4, okay? And that'll end up canceling this label. Then we need to get our mole canceled and go to our energy. So we've got, from our equation up here, 1 mole CH4. And keep in mind, if we were talking about oxygen, it would be 2 moles for oxygen is going to give us the negative 890.4. But since we're only working with the CH4, we only have 1 mole. But this is kind of like our mole to mole ratio when we did stoichiometry. We have to use whatever's in the equation with the energy provided. So now this one's going to be a little bit longer for calculating, but our labels cancel and our label in the end is going to be kilojoules. So we're going to have 22.4 divide by the bottom, so 16.043, and multiply by our 890.4, that's negative, and we end up with a negative 1243.2 kilojoules. And done. So when you're doing the worksheet, we just went through this whole front side. On the back side, you're going to have moles. Now make sure you also determine whether it's exo or endothermic. Okay, but here you're starting with moles. Here you're starting with grams. And here you're also starting with grams. And they're each asking whether they're endo or exothermic. So make sure you're answering both of those in each of these problems. And that's all you're focusing on for today.